Hello viewers, welcome to my channel Knowledge Unlimited, and in this video I'm going to explain how complex it is to design a radar. And you might think how it is possible, but I'm going to explain or bring you the feel that how difficult by using a simple mathematical operation or a mathematical concept called as the probability. And in particular I'm going to use the conditional probability concept. You might think why I'm saying that, but in the coming part of this video you are going to know that why I use the term conditional probability instead of probability. So let's don't waste much time on this. So by taking a simple example of considering all the specifications that a radar need to have, and by considering all of them with a maximum higher best radar which possess these qualities, and let's prove how probable it is to get the desired result by designing a radar with that specification. So let's solve this by using a simple example, and let's see what will happen by the conclusion of that part. Following the example directly, let me explain you why I use the term conditional probability. I already mentioned that. I will explain in the latter part of the video why I use the term conditional probability. And we know that radar is something which will detect the presence of some object. For example, let us consider the desired object in the whole video as aeroplane, and our radar should give the signal if the aeroplane is present in the region of a radar vicinity. So if there is an object, if there is an aeroplane in this region, then our radar should give the indication that there is the presence of aeroplane. And in the other cases, it should not give any signal of presence of aeroplane. So now you can see that for everything there are two sides, like for coin there are two faces. Here also there are two cases that there might be chances that the presence of aeroplane, if we take that the presence of aeroplane as one event, then its complement part is the absence of plane in the region. So I am going to notate it as B in this example. So if there is an presence of aeroplane, then it is called as B, and if there is an absence of aeroplane, then I will notate it as B complement. So there are also chances that our radar may not be 100% true according to our specifications. So if it gives correctly, let me call it as B, and if it gives a false alarms, then that event I am going to indicate as A and A complement. So let me take an example to give you more clarity. So in real life situations, we may not see all the time the presence of aeroplane in this radar region. So I am going to assign a least probability for the presence of aeroplane in the radar region and more probability for the absence of aeroplane in the radar region, which is quite more convincing for us to assign that. So if A is an event of presence of aeroplane, so don't consider this. What we are considering here are more important. So let me give P of A equal to 0.05. This is the probability I am assigned for the aeroplane to be present to be flying. Let me take it as the probability for the aeroplane to fly, and P of A complement will be 1 minus 0.05, which is 0.95. This is the probability that aeroplane is not in the radar region. Now we can assign two more probabilities. That's why I use the term conditional probability, because conditional probability is nothing but occurrence of an event. Depending on the occurrence of an event, another event will be occurred. If this is my sample space, this is my event B, and if this is my event A, then what is P of A by B means the probability of occurrence of A after the event B has occurred. So this is a probability that event B is occurred. So this is my common area, where this is a probability in which the event A will be occurred after the occurrence of event B. So with that basic knowledge of conditional probability, we can proceed here that now I'm going to write the probabilities of radar. So now let us take the best specifications that a radar can have. So if there is an plane in the region, then my radar will give 99% correct value, that is 90.99 probability. Means if there is a presence of aeroplane in the radar region, then my radar will give me a signal that there is a presence of an aeroplane. And we cannot design 100% specifications, user specifications, or 100% product. So let us give a radar which is not giving any signal even though there is a presence of aeroplane, so which is least probable, so 0.01. here why I am stressing is I am designing the maximum best specifications radar here. So I have given 99% it is accurate and 0.01% it is inaccurate. So in the same way, if you consider the counterpart, again we can divide the true probabilities that the radar giving the wrong alarm in the absence of aeroplane, means aeroplane is not present in the radar region. After occurrence of that event, even though radar is giving some alarm that there is something present, so let me give it a less probability because this will happen very less time or rare condition. So let me give it as 0.05, and it is giving no signal B complement and there is no plane. So after the occurrence of event that there is no plane, our radar is not giving any signal, which is rather required specification. So I am giving it more probability. I am assigning it as 0.95. So now from this we can take 4 values, that is P of B by A, which means the occurrence of event B after the occurrence of event A. Now I am not going to explain every time that event A is a presence of an aeroplane and event B is the radar giving the signal. So because it may take more time just for saying those things, so you can relate or them for each and every time I say B and A, that there is a plane and the radar is detecting about the plane, or there is no plane even though radar is giving signal, and there is no plane and radar is not giving the signal. So these are the various possible cases that may present in this example. So now we have all the 4 cases that are required. Now what our necessary specification or necessary thing that is to be found is P of A by B, which means that the probability of occurrence of event A after the occurrence of event B. Now if you relate these in terms of a radar and aeroplane, what it says is the radar giving the signal means P of B after radar gave the signal, that is the occurrence of event B. Event B occurred means radar gave the signal. Now event A is there is a plane present in it. So the radar gave the signal and the plane is present. So radar gave the signal and the plane is present. So this is the meaning of P of A by B. So after a radar giving so let me elaborate it. Radar gave the signal, and after occurrence of this event we are going to see is there is a plane. A means as there is a plane. So how much value we will get here will give the conclusion of this example we have considered. So now let me find first P of A intersection B, which means P of B by A into P of A, the occurrence of event A, the occurrence of event B after the event A has occurred, into the probability of aeroplane flying in the air will give my common part, that is P of A comma B, which is equal to P of V by A is 0.99 into P of A is 0.05. P of A is the probability that aeroplane present in the air, 0.05. Now let me use my calculator, and the value is 0.99 into 0.05, which gives rise to 0.0495. Let me put this value aside. Now let me calculate P of B, that is the radar giving the alarm, which is equal to 0.95 into 0.05. I'm multiplying this to P of A complement into P of B by A complement, plus here also we have some common term, that is 0.05 into 0.99, which gives my whole value of it's the radar giving the alarm. Let me take down these values. 0.95 into 0.05, which is equal to 0.0475, plus we have still two more values, 0.05 into 0.99, which gives rise to 0.097. Now I have my P of A intersection B and P of B. Now from these two values I can calculate P of A by B, which is equal to 0.0495. we got here 0.0495 divided by 0.097. now let me take down these values. That is 0.0495 divided by 0.097. oh, that is 0.51. I am not writing remaining figures which are not very necessary. So it is 0.51. now I am going to write down here P of A by B equal to 0.51, which means it is of 51%. Now you think about it, what actually happened. We have taken the best specifications here, that is 99% it is detecting correctly, and a 1% is not detecting correctly, and a 5% it is giving a false alarms, but 95% it is working correctly of not giving any indication if there is no plane. But what finally we got here? P of A by B. What does this mean? That the event of occurrence of B is already happened, and after happening of event B, the event A occurred, and this is 51%. So what actually means, the radar is giving the alarm, and after the radar giving the alarm, we are going to check what actually happened. Is there any plane or something? And after checking that, there is a chance of really having a plane in that region is just 50%. What does this mean? By considering such very high specifications also, we came to a conclusion that it is 50% correct, that even though the radar gives us a signal, the presence of plane is only 50%. So what if we take about here 99%, 1%, and what if we increase this value about 10% and 90%, the probability will come down. If I change these values to 0.10, you do the same calculation part. As the video time is becoming more, I'm not going to do here. Then we will get just about 34% accurate value, that if we got the alarm and if you go and check, there is a chance of plane being there is only just 34%. So this gives us the feel that even though we have considered the best specifications to design a radar, but the chance of being a plane present is very less, that is exactly 50%. So this gives a feel that how complex it is to design a radar, which nowadays a defense or so many real life situations we are using the radar, which are about 80 to 90% successful. Means how complicated it is to design. Still we have to increase the specifications to get the best results. Hope you guys enjoyed this video a lot, and if you do really, then share this video and like, and please comment in the comment section, and thank you for watching. Please subscribe for more videos.